right? To illustrate the concept of conflicting instructions, we consider Schedule 3 in 14.6. So the write of A instruction conflicts with read of A instruction of T2, right? So what we do is that we are going to write a Schedule 3 which shows only the read and write instructions, right? So Schedule 3 is a version of refined version of figure 14.4 Schedule 3, right? So here we are going to show only read and write operations. Read of A, write of A in T1, read of A, write of A in T2, again followed by read of B, write of B in T1, and read of B, write of B in T2, right? So this is going to be the equivalent version of Schedule 3 showing only the read and write operations, right? So we are focused only on read and write operations. So to illustrate the concept of conflicting instructions, we consider the Schedule 3 in figure 14.6. So the write of A instruction of T1 conflicts with the read of A instruction of T2, right? So in transaction T1, first you have write of A instruction of T1. It conflicts with the read of A instruction of T2, right? So however, the write of A instruction of T2 does not conflict with the read of B instruction of T1, since they are going to refer to different data items, right? So however, the write of A instruction of T2 does not conflict with read of B instruction of T1, because two instructions are going to access different data items, right? So I hope you are able to follow it, right? So we are going to consider an equivalent schedule of Schedule 3 showing only read and write operations. Here, if you look into it, in transaction T1, there is a write of A operation, and transaction T2, there is a read of A operation, right? So T1, there is a write of A operation, and T2, there is a read of A operation. So there exists a conflict between write of A instruction of T1 and read of A instruction of T2, since they refer to the same data item. However, there exists no conflict between write of A instruction of T2 and the read of B instruction of T1, since they are going to refer to different data items. So the idea is that we can swap the instructions if they are without any conflicts. So we are going to swap read of B instruction with write of A instruction. Right. So let I and J be consecutive instructions of schedule S. If I and J are instructions of different transactions, and if I and J do not conflict, then we can swap the order of I and J to produce a new schedule S dash. Right. So S is equivalent to S dash, since all the instructions appear in the same order in both the schedules except for I and J, where order does not matter. Right. Since write of A instruction of T2 does not conflict with read of B instruction of T1, we can swap the instruction to generate an equivalent schedule, schedule 5. Right. So write of A instruction is being swapped with read of A instruction. Sorry, yeah. Write of A instruction is swapped with read of A instruction. So we are going to continue perform the swap process. So swap the read of B instruction of T1 with the read of A instruction of T2, and you can also swap the write of B instruction of T1 with the write of A instruction of T2, and finally swap the write of B instruction of T1 with the read of A instruction of T2. The final result of this swap will result in a schedule which is a serializable schedule, right? So if a schedule S can be transformed into a schedule S dash by a series of swap operations of non-conflicting instructions, we say that S and S dash are conflict equivalent, right? So initially it was read of A, write of A, followed by read of A, write of A, then only you have read of B, write of B. Now we have swapped read of B and write of B with read of A and write of A instructions. Now it's a serial schedule. so that you will be able to execute the instructions without any conflicts, right? So I think I think you are able to follow this, right?
Yes, sir.
Right. So let me explain it again. So we are going to convert this schedule into a serial schedule, right? So this is a concurrent schedule, right? Figure 14.4, schedule 3 is a concurrent schedule where two transactions are executed concurrently, one after another, right? So we are focused only on read operation and write operation on a data item capital A. So we are going to have a equivalent schedule like this format, right? So the equivalent schedule is going to be read of A, write of A, read of A, write of A, read of B, write of B, read of B, and write of B. So this is the equivalent schedule of schedule 3 that we have seen long back, and concurrent schedule that can execute without any conflicts, right? So conflict serializability, you have four conditions. You have transaction TA containing a instruction I that performs read operation on a data item capital Q, and a transaction TJ containing an instruction J that performs read operation on the same data item capital Q. Right. So both of the instructions can proceed concurrently, since the same value of the data item Q is read by the transactions TA and TJ. Right. So if both the transactions TA and TJ, they want to perform read operation on a particular data item capital Q, they can proceed without any conflicts. However, if one transaction is going to perform read operation on a data item capital Q and another is going to perform a write operation on a data item capital Q, right? Then the order of the occurrence of the instruction matters, right? So the third case is going to be transaction Ti. We are going to perform write operation on a data item capital Q, and transaction Tj, you are going to perform read operation on a data item capital Q. Here also the order of INJ matters for the reason similar to the previous case. And when both instructions are going to perform write operations on the same data item, the instructions does not affect the transaction TI or TJ. However, the next instruction following the read of Q, the next read of Q operation is affected, right? So what we do is that we are going to consider schedule 3 where the write, so if you look into this schedule 3, the write of a instruction is going to conflict with the read of a instruction. However, the write of a instruction of T2 does not conflict with the read of B instruction of T1. So what we do is that we swap read of B with the write of A instruction. Then you swap read of B with the read of A instruction. Similarly, you swap write of B with the write of A instruction, and you swap write of B with the read of A instruction, right? So once you perform this four swap operations, you have read of A, write of A, followed by read of B, write of B instruction in T1, and then you have T2, you have read of A, write of A, followed by read of B and write of B, right? So we'll be performing a series of swap operations, and you get this uh, serial schedule from the concurrent schedule. So now you can say that this instructions can proceed without any conflict, right? So if a schedule S can be transformed into a schedule S dash by a series of swapping operations of non-conflicting instructions, we say that S and S dash are going to be conflict equivalent. Now both instructions, sorry, now both transactions can proceed without any conflicts, right? So this is the idea behind conflict serializability. So I hope you'll be able to understand it. You can have a look into your textbook, right? So it's quite easy only, it's simple only. Maybe next class we'll study something more about it. I will be able to follow this, right? So you are going to transform a concurrent schedule into a serial schedule so that the transactions can execute without any conflicts. It's known as conflict serializability, right? So thank you for your participation. Right. So we'll meet during the inauguration of the CSA Association. So I invite you all for the inaugural for the CSA Association scheduled at 2 o'clock today afternoon. So we have chief guest from Samsung Electronics. So we got him through Samsung Research Institute. So we have some projects with Samsung Research Institute, right? So he is working in as a group for big data analytics. He was a director of Walmart, and he also served as a director in Samsung some time back. So I would like to invite you for this inauguration of our CSA association, and I would like you to attend the workshop or his guest lecture on big data analytics, right? So we'll meet
Yes, sir.
during, yeah. So we'll meet during the
Yes, sir.
inauguration. So I hope that it will be useful to you.
Thank you,
Yes,
sir.
sir.
We'll attend.
Thank you, sir.
Okay, sir.
Thank
Thank you,
you,
sir.
sir.
Thank you for your participation. We'll meet in the next class.
Yes, sir.
Thank you.
Yes, sir. Thank you.